All right, let's do a really complicated one, or one that looks really complicated, but we'll see it's actually not too bad. So we'll do f of x equals x to the 3/5 power. 3/5 power times the square root of x squared minus 2x over x cubed minus 5x cubed. Okay, wow, right? We could use the product rule, the quotient rule, and the chain rule to solve this, and it would take us probably a week. Or we could use log differentiation. So let's do our different steps. Let's do step one, which is we set this to y. So f of x becomes y equals x 3 over 5 square root of x squared minus 2x over x cubed minus 5x cubed. Okay. Then let's take the natural log of both sides. So the natural log of y, and then we're going to do the natural log of this whole thing. Now, if we really need to know our log rules or log laws, so if you don't know them, review them. But what we actually have here is we can think of this in two distinct chunks. We've got the natural log of this plus the natural log of this, because the log laws say if you have two things, if you're taking the natural log or the log of just something like this, if we have the natural log of a times b, this is the same as the natural log of a plus the natural log of b, right? Similar to the product rule. So we can split these apart. So we can take just the natural log of x to the 3/5 power and then add it to the natural log of all of this. Well, we actually have another log rule, which is that if you have something divided by something else, that is the same as the natural log of one part subtracting the natural log of the other part, right? Subtracting the top from the bottom. So in this case, we can actually do plus the natural log of, I'll put this in parentheses, x squared minus 2x minus, right, because now we're going to minus this bottom part, the natural log of x cubed minus 5x, all of that cubed. Okay, now let's simplify this down a little bit. So, all right, we've got, again, knowing our log laws, we can make this a heck of a lot more manageable. So if I'm just paying attention to each term, this can be popped out and put out in front, right? So we can do 3/5 times the natural log of x, okay? Plus, now again, you need to know your rules, but we can pop out this as an exponent. So this is actually the same. A square root is the same as to the power of 1/2, right? So like if I do 5, square root of 5 is the same as 5 to the 1/2 power. So I can just treat this square root just like this first one where we reach the 3/5 power. Instead, it's to the 1/2 power. So I can just pop out that 1/2. So plus 1/2 the natural log of x squared minus 2x. Okay, already that's getting way simpler. And then we've got this minus, and again, I can pop that 3 out. 3 natural log of x cubed minus 5x. Okay, not too bad. Now this is actually manageable, right? Equals the natural log of y. Now we just need to basically differentiate this whole thing, right? And find the derivatives of all of our different chunks. So let's do that. So let's do the derivative of this, which is the same every time, right? The f of x derivative is always the same. It's always going to be 1 over y times y prime, right? Every time, the derivative of y, dy dx, however you want to write that. Let me do this in a different color. Equals, all right, now we've got this 3/5 times the natural log of x. So how can I derive this? Well, I can use the product rule, right? So here I'm going to do each one of these chunks a little separately. So I'm going to do this one in brown. So 3/5 natural log x. So I can do the product rule, right? Where instead it's 3/5 times natural log of x. Okay, and let's do the derivative of each one. So the derivative of this is 1 over x. The derivative of 3/5. Well, remember, this is a constant value. So what's the derivative here? 0, right? Any constant values, right? It's just graphs is a straight line. Any constant value is going to be 0. So that's the derivative here. And then we just remember our product rule, which is g prime x times f of x plus f prime of x times g of x. All right, let's label each one. This one's f, this one's g. So we'll do this first one. So again, the prime is 1 over x times 3/5. Okay, so that's my first one. Plus, and then we got to do f prime. So f prime would be the 3/5, which is 0, times the natural log of x. Well, 0 times the natural log of x is what? It's 0, right? So that's just going to go away. So we're left with this, and we can just basically cross multiply here, right? So we've got 3 over 5x. Okay, so 3 over 5x is the derivative of this. If we want to verify that, let's verify that in Desmos. We can go to Desmos, open our graphing calculator, and just set the function to just be that one little piece. So that one little piece was 3/5, 3 over 5, times the natural log of x. So we've got this right here. And then let's type in our derivative. So g prime of x. Ooh, I'm getting an error here. Oh, I'm sorry, not g. F prime of x, we've got that. And let's type in our supposed derivative, which is 3 over 5x. Ah, it is. Now, remember, we have this domain restriction going on, which is why we're not seeing this other half. But yeah, this is the derivative here. Okay, so we've got the correct derivative. Notice it matches up on this half. That's what we're really looking for. Okay, because we've got a domain restriction. All right, so this is our derivative for our first one. So I can come back over here and I can write in 3 over 5x plus, okay, let's do the next one. I'll do the next one in orange. So we're going to derive all of this. Okay, so we've got, let's see if I can write down 1/2 natural log of x squared. 1/2 the natural log of x squared minus 2x. Okay. So we could do this as a composition plus a product rule. So the product rule would be 1/2 and then times the natural log of x squared minus 2x, right? So that would be our product rule, and then in this half we would solve as a composition. So let's solve this half first as a composition, remembering our composition rules. I'll do this in a different color just so it's a little bit easier to see. This is going to be, we're going to do this larger derivative, and then we're going to plug this back into it for where we see x, and then we'll do just this derivative. So let's do just this derivative first. So the derivative of x squared minus 2x, that's an easy one, right? It's 2x and then minus 2. 2x minus 2, right? That's the derivative of that half. So we know that's at the end, times, and then the rest of our chain. So we'll do, what's the derivative of natural log of x? It's 1 over x. So we're going to do 1 over, and then we do this, right? X squared minus 2x. We plug in the original function back into where we see x in that new equation. So this is our chain rule. We've found this derivative. We can multiply this out, right? This is the same as over 1. So that would equal 2x minus 2 over x squared minus 2x. Okay. So let's leave it like this. I mean, if you want to, you could reduce this down. You can go from there, but let's just leave it like this, right? We could pop the 2 out of this is what I'm thinking. But it's fine. We'll leave it like that. Let's go back over here. What's the derivative of 1/2? Well, remember, it's a constant, so the derivative is 0. Okay. Now coming back here, let me erase this real quick. Coming back, we need to do our product rule. So our product rule is going to be this one times this original. Well, that's easy, right? 0 times the natural log of that is just going to be 0. And then we need to do this derivative times the original here. So we're going to do the 2x minus 2 over x squared minus 2x, this whole thing, times 1/2, right? And again, we're just multiplying across because it's two fractions being multiplied. So 1/2 and 2x minus 2, x squared minus 2x. So treat this whole thing, distribute that out. So we've got 2x squared minus 4x under 2x minus 2. Okay, so that's our next little section. So that gets plugged in right here. Let's see, let's just make sure. Oh, here, and let's verify. Again, we can verify at each stage. Let's verify that this is the correct derivative. So it was 1/2 the natural log of, what was it? It was x squared minus 2x, x squared minus 2x, okay? And there's our derivative in blue. And then let's type in our version of it and verify that we got the right answer. Which was 2x minus 2 over, and of course it's going to freak out a little bit, so let's do that. 2x minus 2 over, and we had 2x squared minus 4x. 2x squared minus 4x. All right, so we've got some funkiness happening here. This actually is also the correct answer here, but you have a domain restriction. What's the domain restriction? Well, this is actually undefined right here. So if we show this, although we get this middle value, it's actually undefined on the original function. So it doesn't show whenever we do this derivative here. But if I look at the other two pieces of the derivative, the blue and the blue, it does match up. It is the same. So this is the correct answer for that one. So we can just come back in here and plug that in. So let's plug that in real quick. We've got 2x. Now I have to remember what I did. 2x minus 2. Over 2x squared minus 4x. Again, you can reduce this down. We're not going to worry about it. All right, now let's do our last one. So we've got minus, and then this right here, 3 natural log x to the 3 minus 5x. So again, we're just doing the same thing. We're just doing a chain rule followed by, chain rule followed by a product rule. So I'll do that on this side now. So it's going to be 3 times the natural log of x cubed minus 5x. So let's do, this derivative is 0. So same thing, right? We're going to have only half of the product rule will apply here. And that half will be 3 and then something else. So now let's solve this chain. So this chain is going to be times the little n section, the derivative of that, which would be 3x squared. And then we have minus 5x, so that's just going to be minus 5, right? 3x squared minus 5. And then all of that being multiplied by the natural log. Well, what's the derivative of the natural log? 1 over x. Again, now you're seeing why we use natural log and not just log 10 or log 3 or whatever. So 1 over x, and we multiply these out. So 1 over x times 3x squared minus 5. Oh, I'm sorry, I totally spaced on this. We need to plug back in our original function in here. So to plug that in, that'd be 1 over x cubed minus 5x times 3x squared minus 5. I'll put that all over 1 just so I realize that I'm multiplying across. So what we get is 3x squared minus 5 over x cubed minus 5x. And then that is going to get multiplied by 3, right? Because again, we're going back to that product rule. It needs to all get multiplied by 3, which is the same as 3 over 1. So we just multiply across. So that's 9x squared minus 15, right? Multiply this into each one of these over x cubed minus 5x. All right, so let's double check that in Desmos again. So in Desmos, I'm going to do my original, which is 3 ln 3 natural log of x cubed minus 5x. Very funky function we've got going on here. And we'll type in 9x squared minus 15. So g of x will equal 9x squared minus 15 over x cubed minus 5. Is that right? Minus 5? 5x. All right, same situation, right? We've got some domain restriction that has to happen here, so you can kind of eliminate this one and eliminate this one. But we match up on our other ones, so we are correct. So let's come back in here and we're going to write that value in here. So minus the whole of, just to be clear, I'm going to kind of put these each in parentheses, minus 9x squared minus 15 over, over x cubed minus 5x. Okay, so this is our new derived function. Now we need to multiply this whole thing by y. All right, so remember, because we're gonna, to get rid of this, we're gonna be dividing by a fraction, which means we're really multiplying by y. So we're gonna put all of this, I'm just gonna put all this in a big bracket, 3 over 5x plus 2x minus 2 over 2x squared minus 4x minus 9x squared minus 15 over x cubed minus 5x, okay, times y. And what's y? Our original function. So times all of this, right? F of x. So times x to the 3/5 power, the square root of x squared minus 2x over x cubed minus 5x cubed. That is our final derivative. This times all of that. Now, this is fine. You can leave it like this. You do not need to go through and rewrite this in terms of x. That would be a lot. So let's try and type this in. We'll see if it's possible. It's kind of a nightmare to type on Desmos, but let's see what we can do. So I'm going to eliminate that, and I'll type in the original function. So we're going to do x to the 3/5 times the square root of x squared minus 2x over x cubed minus 5x cubed, close parentheses. Wow, what a function. What a crazy function. And here's our derivative, and let's see if we've got something close to this. So we can actually do this. We can just plug in f of x rather than having to rewrite this, but if you really want to, you could copy this and paste it in. But instead, I'll just type in f of x. That's just saying insert that whole function in here. That whole function is going to be multiplied by the new part that we wrote down here. 3 over 5x. Okay, so that's the first part, plus 2, plus, and we'll do this in parentheses, 2x minus 2 over 2x squared, was it plus 4? No, minus 4x, okay, minus, and then we'll do this in parentheses as well, minus 9x squared, 9x squared minus 15 over x cubed minus 5x. Wowie, wow, we did it. Right? It's kind of mind-blowing to think we were able to just find the derivative of this function using this. I mean, pat yourself on the back if you made it this far.